we have built a virtual slow motion camera where we can see photons or light particles moving through space. Now, you have seen Dr. Jordan's pictures of a bullet through an apple. But photons travel about 1 million times faster than bullets. So our camera can see these photons or bullets of light traveling through space.
We use a very regular pulsed light source and a camera that is not one camera, but an array of 500 sensors, each triggered at a trillionth of a second delay. So even though each of our sensors is slow, we can still capture a fast movie. I'm standing next to our laboratory setup here. This is our camera. Objective is in the front here. The body of the camera is much larger than what you would expect from a regular camera like the one over here. Our light source is a titanium sapphire laser that's over here, and it emits a beam of very, very short pulses, and those pulses are then directed to the scene with these mirrors. Now, our camera only sees one dimension, so it makes a fast movie, but it makes a fast movie of one line of the scene only. And in order to fix that, we have these two mirrors here. We look at the scene via these two mirrors, and when we rotate this upper mirror here, we actually see different lines of the scene. So what's happening is the camera keeps taking images, and we very slowly rotate this mirror to scan our field of view across the entire scene. And because all of our pulses look the same, we can in the end go and combine all these images that we took to get one complete movie of the scene.
Such a camera may be useful in medical imaging, in industrial or scientific use, and in the future, even for consumer photography. In medical imaging, now we can do ultrasound with light because we can analyze how light will scatter volumetrically inside the body. In industrial imaging, one can use the scattered light to analyze defects in materials. And in consumer photography, we are always fascinated with creating lighting effects that appear to come from very sophisticated light sources. But because we can watch photons seemingly moving through the space, we can analyze the transport, the movement of these photons, and create new photographs as if we had created those expensive light sources in a studio.